Okay, that was perpendicular bisector, so now we're going to move on to the perpendicular bisector converse. And that means that we're going to start with our sides being equidistant, and because of that we know, so I'm going to start with an isosceles triangle. Okay, and when we start with an isosceles triangle, then we can say that the top down to the bottom is a perpendicular bisector. Okay? So if I ever give you an isosceles triangle, you know what to do. So if I give you this information, at the bottom 17x minus 3 and 9x plus 13, you know that this is congruent to this one, so their measurements are equal, and we know how to put that into a formula now. 17x minus 3 is equal to 9x plus 13. Okay? And then we go, and we get x equals 2. Okay, remember guys, if you need to pause it, I might be going a little bit quickly, so just pause it before I can start talking about the answer. So that's perpendicular bisector and its converse problems. Okay, so let's move on to the angle bisectors. If you want to pause it and review your angle bisector notes right now, go ahead and do that. Angle bisector looks really different than perpendicular bisector. The problems look really different, and on the quiz I'm going to tell you what you're working with at each point, okay? But we know that if I have an angle, okay, and I bisect it, okay, of course the bisector means that I did that with it, then any point on that angle bisector will be equidistant to the rays of that original angle. So this congruency right here is the conclusion of that theorem. Okay. So what if I gave you that this is 4x plus 30? Well, let's erase this. This is what it'll look like on the quiz. It'll look like this. And you can see that this is two triangles. It's not one triangle because this side is not one line, right? So you can say, okay, well, this is angle bisector. I know it looks a little bit weird. So this one's going to be 4x plus 30, and this one is going to be 9x minus 5. You can pause right here if you want to solve for x. Okay, so we know, because this is an angle bisector, I know that because of my congruency lines and all of this, then I can say this one is congruent to this one. I set up my formula. Doing all of the math, okay, I'm going to move to my smaller coefficient. 35 equals 5, what is that, 5x, and x equals 7. Okay, that's the answer for that one. Okay, so let's try a converse of the angle bisector theorem. Okay. A converse says, if I start with points equidistant on a line that cuts an angle, then it is an angle bisector. Okay. So it'll look something like this. Actually, this. If I give you that this angle measurement is 5x plus 11, oh no, minus 11, sorry, and this one is 8x minus 41, go ahead and do this problem. You can pause it. Okay. However, I'll explain it. So, oh, sorry. This is congruent to this. This is the requirement of the converse. These sides need to be congruent. So if these sides are congruent, then these two are this line is an angle bisector, which means that these two angles are congruent. 5x minus 11 equals 8x minus 41. And doing all the work, I get x equals 10 degrees. Or not degrees, just 10. Okay? So if I plug it in to this one, I'll find out what this one is if I plug it into this. Well, I don't need to plug it into this one. These two are equal. Right? Okay, so that's angle bisectors. Let's move on to circumcenter. And I pointed out earlier that circumcenter is connected to the perpendicular bisector because the perpendicular bisectors all intersect at this one point called the circumcenter. Okay, so let's do that. If I have a triangle, well, I'll just draw out what it should look like. Okay, so here's my perpendicular bisector. Here's another perpendicular bisector, and here's my last perpendicular bisector. Okay, this is my hypothesis. If I have this, if I have a circumcenter, then that circumcenter to the vertices are all congruent. So I can make a congruency symbol for that one. That's just a reminder for what you should be filling out the diagram to look like. And I'll remind you again that you will lose points if you don't fill out your diagrams all the time. So don't forget to do that.